Why, hello and welcome back. Stumbling on my words there a bit. They're not going to be perfect every time, but welcome back. Hello to the new viewers. Today's an exciting day. Today we start applications of derivatives. First thing I have for you guys, implicit differentiation. Now, at the start of our limits, we talked about functions, and I'm sure we've talked about functions lots in the past. But what if we want to find the derivative of a relation? Something like the unit circle. That's an interesting question, isn't it? It's not that bad. And it'll be interesting, the chain rule becomes a part of this. So, this is the unit circle. Its equation is x squared plus y squared equals 1. We know this because of Pythagorean theorem. Fun stuff it's been banged into our brains for years now. If you went to school where I went, I mean, I've been doing this for 8 years now or something ridiculous. But yeah, let's differentiate this. So we might remember from any basic algebra understanding that if we differentiate both sides, if we do anything to both sides of an equation for that matter, you're going to get the same thing. Or in other words, the equation will still hold. The equal sign will still mean equals. But how do we differentiate y with respect to y? Well, good question. Let's just go ahead and get into it. So we're going to take the derivative with respect to x of x squared plus y squared equals the derivative with respect to x of 1. Now, we know from knowing what derivatives are, that's just going to be 0. So, we can take the derivative of x squared, that's easy. That's just 2x. Now, we can remember from the chain rule that we will have to treat y squared as a function because it could be represented in terms of x, or kind of. It's a good way to think of it, but not exactly. So, let's take a look at this. Well, what we're going to have is we're going to do 2y, right? We're going to differentiate with respect to y. And let me just write the chain rule over here for you guys. If we want to take the derivative with respect to x of y squared, what we're going to get is we're going to get the derivative of what we're going to get. What this is, we're going to get 2y. What we're going to get is dy over dx, because what we can see is that our y squared is going to be our u, like we talked about, kind of like a u sub. But yeah, so what we're going to get here is times dy over dx equals 0. So we can just rearrange this. 2y times dy over dx equals 2x. And we can get dy over dx equals, well, these 2's cancel out. It's just x over y. So what that tells us is the slope going, the rise, the small rise over the small run is equal to our x value divided by our y value anywhere on the unit circle. So that holds for up here, anywhere on the circle. Perfect. That's what we're looking for. So that's implicit differentiation. Thanks for watching.